Hello YouTube, I was going to go ahead and show you the next parts of this. You got these units, and I'm going to give you heads up. You can see, you know, I got my micron gauge over there, I got my new manifold set hooked up, and my meter's over there running, everything's working right now. We got, you know, see the drinks, because it's 140 degrees on this roof. I mean, it is what it is. It's just too damn hot to stay up here continuously. I have to go down and up and down and up. I'm sorry I ain't going to be able to do a bunch of content, but I am going to show you the next part of what I've been doing. Follow me. Let's take a closer look at what's going on here. I'm sorry if you can't hear me neither. I got a really bad headache and I don't want to yell, so please forgive me. And we got this suction line leaking refrigerant right here. We're going to fix that. Once that's fixed, we're going to test it with a micron gauge. Once we make sure it'll hold below 2,000 microns, we'll pull it down to about 1,000 and, you know, put refrigerant in it. We're putting this new type of refrigerant. It's called 407C refrigerant. It replaces R22 refrigerant, and it's apparently working pretty well on the other units. I mean, you know, these are only 2 3-ton units, and this place needs about 2 5-ton units. So, in all reality, it should work a lot better when I'm done. They're going to be a lot happier, and I think it's going to be really cool. So this is what's going on next. I'm going to pull all the refrigerant out of this system, and once it's pulled out, I'm going to put a filter dryer in here, a sight glass in here. I'm going to fix the leak that's right here, and then I'll be done with this unit. So once all that's done, we're gonna charge it back up. Luckily it's shut down, it's too low of refrigerant. The temperature on the tank is too high, so we're just gonna have to let it remove some more heat. It's really hot. I've got the tank sitting on top of where the fan runs. I'm letting the fan sit there and run over where it's at to try to remove some of that heat off the tank. I got a big feeling it's going to take forever to get this refrigerant out. The biggest problem is because we don't have a port on the liquid line. So basically we're trying to remove the heat that's in all the refrigerant that the evaporator coil is heating up. So the evaporator coil is heating this refrigerant, and I got to remove it with the fan on the top of the unit blowing on the tank. So there's not a whole lot you can see right now. So what I can do for you is I'm going to press pause, and then when I start soldering the connections, I'm going to go ahead and start recording again so you can see me soldering the connections. Okay, YouTube, what I'm going to do is I'm going to remove this 90 that's right here. I'm going to put the correct size 90 on it. It's called a street 90. This is a street 90. You can see how it flares out. The 3/4 inch copper goes on this, and this goes into the compressor. So this is what you call a street 90. You know, the 3/4 inch copper flares out, and the other side it doesn't flare out. This is 3/4 inch copper, inside diameter, outside diameter, where it's going to go. So it'll fit just like that on there. If I can get it to fit good. Let's hope I can. You can see a lot of smoke because the oil's been coming off of it. You may even see a fire. Today I picked up the wrong torch tip. I might have to go down to the truck and pick up a large one. Now, I've got this pipe, and you can see the difference in this pipe. This is a 7/8 street 90. This is a 3/4 inch street 90. And it just fits right inside the compressor. Look at that. It just fits perfectly inside the compressor. You know, we got this thing's really hot. I'm gonna put it on a unit. That way it doesn't burn the roof, because this roof is a certain type of roof. We don't want to burn it, so. Alright. That's going to have to cool off. It's really hot. I'm not going to be able to work with it while it's. Alright, I'm going to go get some water and get rid of the heat. Be right back. Alright, so here's my water. We're going to get rid of the heat by putting water on this rag. The temperature outside's coming down a lot. I've been up here for 6 hours now. So I poured some water on it, and then I'm just trying to soak up what water I can off of the ground. Once I get it cooled off where I can handle it, I'm going to bend it into shape to where it'll fit. Once we get this done, we shouldn't have any more leaks, but I'm going to test it with a micron gauge and since it ain't blazing hot and I got to run off the roof as soon as I start the vacuum pump, I'm going to show you, because it's cooling off a lot. The sun's not hitting us nowhere near as hard. It's at an angle, and I'm shaded by the unit too. And you know, I'm just really happy that I'm able to continue, because I thought I was going to have a heat stroke. It was so hot out here. I mean, I've already drank over a gallon of water since I've been here on the job. So I think I'm going to cut this off right here. That way I can bend it into shape better. So get your handy dandy tubing cutters. So this copper has been abused. Before I came here, all this stuff was put in wrong. The solder joint wasn't sealed. It was leaking around the connector. This copper's been wrinkled right here, and it's just been a mess. I'm not sure what company's been working on this, but man, they've been beating these guys to death. So what I'm going to do is I'm going to start coming out here every month and checking the temperature output, checking the units. I'm putting sight glasses in here so I can just, you know, swing by, take a look, get on the roof, see if there's low on refrigerant, change the filters, and take off. You know, the owner just wants me to be out here on a regular basis, do the maintenance. You know, when something goes wrong, he wants to be able to trust me, you know. And I came out here and I showed him what I'm going to do, and he was really happy with it. So this is how I'm going to solder it. We got two simple joints. It's a lot simpler. If you haven't noticed, it's going to look a lot better, hopefully, if I can figure out how to do soldering. I bought the wrong torch tip, and this thing doesn't get hot enough. I'm telling you, that was $21 a waste of money. You got to get the bigger torch tip. This is a 0, and I thought that 0 was bigger, so I'm wrong. So remember that. You know, I had worn out torch tip, and I just got the wrong one. I've got about 5 sticks of silver laying on the ground beside me, prepared for me to use. What I like to do when I'm soldering these joints is I like to heat this copper, the copper that's on the inside first, because it's going to suck in the copper that's on the inside and seal it on the inside ring. But I will intentionally add additional solder to the outside parts. So I can see that it's melting directly to the copper, and then bam, it just flows right on. The hotter the better, get done quicker. I always go under the bottom like this, because if you have 2 teardrops, it's very likely that in the center there's a hole. So also, after I get done with that, I back my torch off far away, and then I slowly add additional solder, and that puts a nice thick layer of solder around that edge. So again, remember, I'm heating up this connector, which is going to be attached to the inside of the compressor pipe, and it is soldering very well. It's doing well. So I can see that it's doing a good job, but since it was leaking so bad, I'm going to add a whole lot more solder around the edge when I'm backing it off. It's hard for me to see around the edge. I'm sorry if I get in the way of the camera. So it looks like I got a good coverage around it. But it also looks like that the solder isn't sucking up to the tank. It used to be copper, but they got this connector so hot it melted the copper off of the steel, because it's a copper coating on this. So I'll lay it real thick, and there's a certain color and shine that I want to get out of this unit. So I back off the heat a lot, and there's a certain color and shine, and I'm not hitting it in that spot. So, since I'm running lower on that stick of silver, I don't want to burn my fingers. I just heat it up. Now, I'm ready to do a vacuum. I'm gonna go get my other, I'm gonna get the vacuum pump and go ahead and start pulling a vacuum on it, just to check to see if it's leaking. After I do, I'm gonna put a filter dryer right here and a sight glass right here. So I'll be back shortly. I'm gonna go ahead and start checking the microns to make sure that I'm not leaking refrigerant in the future. So basically I just soldered that joint up, and we're gonna get that filter dryer in, we're gonna get that sight glass in right there, and then we're gonna be charging it back up. I'll be back in a second. So YouTube, right now I'm pulling a vacuum through this hose that goes to the vacuum pump. I've completely disconnected this because this manifold has been giving me difficulties. I'm using it as, you know, as I know how it works, but I'm not going to try to explain it. It's been a good manifold for 5 years. I've replaced the tops on it about 10 times, and the internal parts don't close anymore. So it'll keep flowing refrigerant in between the ports. So it'll flow through here and it'll flow through here. It's really old, and it's replace time. I can replace these gaskets in here if I wanted to, but I like new and shiny, so I went ahead and got me a new manifold set, and you know, I can fix that here soon. That way I can do tests on units at the same time. I can still test with it. It's just, you know, it's not real good for pulling vacuums. I think it leaks a ton everywhere. Right now we're pulling a vacuum. We got our micron gauge right here. It's hooked up. It'll take a little while for the micron gauge to start engaging below 760,000 microns. We're pulling from the highest location right here, which, you know, I don't think it really makes a big difference either way. Other than that, we're just moving along. And it's I need to go ahead and get our stuff done for the filter dryer and stuff, so I'm gonna get that ready. Be right back. Okay, this is my sight glass. If it's green in the center, it's dry. If it's yellow in the center, it's wet. You can see it looks kind of wet right now. Once I pull a vacuum into microns, that'll turn green. Then we got a high acid filter dryer. This is a catch-all reversible heat pump type filter dryer. Gotta love it. So we're gonna put it right here. That's in between the that's the liquid line in between the evaporator coil and condenser coil. So, you know, that's going to be our cool line. We're going to cut this line here. We're going to put our filter here, and then we're going to put our sight glass like right here on this line here. Once that's done, we'll be able to charge the unit without worrying about specifics, because we're using a new type of refrigerant. As long as it's got liquid going to the thermal expansion valve or metering device, we're okay. So you got to always take that in consideration. The most important thing is having liquid at the thermal expansion valve or metering device, which could be a piston restrictor. And currently we're down to I don't know if you can see that, yeah, 160,000 microns. It's going to keep going down. We have to break 2,000 microns before I consider it the leak repaired, or we may have more leaks. So once we get down to that, I'll be back with you here shortly and I'll show you. Okay, what we got here is a micron gauge, and we're rapidly going down. I'm really comfortable with it, but I don't care. I'm going to wait until it's around 1500 before I decide to make my change, and I'm going to purge it out, purge the whole system, put our filter dryer in it, and put our sight glass in it, and then we're going to be done for, you know, this unit. We're just trying to fix the refrigerant leak, because this unit was low, the other unit was low, and I don't think anybody ever figured out how to charge these units professionally. You're supposed to use subcooling and superheat to charge equipment, and if you don't, then you're not charging the system completely. On a commercial application where you're in a kitchen, it's not rare to see 80 to 100 psi on the suction side when you got 100 degrees inside. So just remember that. If you're charging a unit on a commercial unit, it's got to remember, if it's really hot inside and they keep making heat, the only way to get rid of it is through air conditioning. And if you undercharge it, they're just going to be uncomfortable. So you don't want to go over the max amps of the compressor, so you got to monitor the compressor running. I've got two identical units here. Conveniently, I already know exactly how much refrigerant I'm going to put in it by weight, but I'm always going to monitor the amps. It looks like our micron gauge turned off. It's okay. It's almost 2,680. Once we get that down, we're going to replace put a filter dryer in it and put a sight glass in it. That's going to make him real happy. He's going to be able to hop in there and take a look, make sure everything's okay, and then, you know, we're good. So I'm going to go ahead and press pause for this, because this takes a long time. I know it came down from 4,000 to 2,500, but you're just going to have to wait. This thing takes forever. Once you get almost to 2,000 microns, it takes a long time to get moisture or any liquid refrigerant that hasn't evaporated out of the oil. So we'll be back in a second. Okay, I went ahead and pre-assembled this. I soldered the joints before I was going to put it in. I kept it nice and cold with a rag and water, because there's a gasket inside of this connector, and there's material inside of this that absorbs moisture. It's a super absorbent, and we got a, you know, it's a bi-flow, so we're going to go ahead and put it in, and you can see that the color has actually changed since I've got it in a hot. You know, the color's changed to green, so I'm going to cut this out, sand the connectors down, and solder it up. Okay, so I got it cleaned up here. You can see it's shinier. I got it cleaned up here. It's easier to go ahead and sand it before you cut it open. That way you can just put it in place and solder it. Now, I do have to have these wires off of this connector, because this is a 3-phase wire for the electric heater, and it's going to get hot if I let it touch. So I'm going to want to keep this cool over here during the process. So let's go ahead and cut it out. So I'm gonna eyeball it here. I'm gonna leave a little extra on there. Pull that wire up with some electric tape. Just gonna stick it right there, wrap it around, just to keep it off of that copper because it's gonna get hot. I don't want it to burn. Okay, so we only got 2 joints to solder. It's a lot easier to solder these joints when they're, you know, when there's only 2. If you got 2 additional, it makes it a lot harder. So I recommend soldering this while it's outside, especially around the under lip of this is what I call it, I guess. But you can call it whatever you want. And you know, this is some scrap copper that I'll have to use for another job. So let's go ahead and braze it up. Like I said, I keep a bunch of silver right beside me whenever I'm working. When it's getting hot, I don't want it to cool off. So here we go. See all that oil? It's there. So like I said before, I get the copper that I'm sweating too hot on the inside first. Because one thing about these filters, it's not, the tip of it's not fully copper, it's just copper coated. So if you get the tip too hot, the copper melts off.